Welcome to the Solving Linear Systems by using the Elimination Method. So I am going to go over some of the other methods that we've used so far, and then we'll jump into the Elimination Method. So if you feel like you're good at graphing, good at Substitution Method, then you can just kind of move along through the video and right to the elimination examples. Okay, so so far we have seen the graphing method. So what that entails is that you have to change the equations to y equals mx plus b form. Then you take the slope and the y-intercept, graph it, and then there's a point of intersection, and that's the solution to the system. That was in the first cycle. So in the next cycle, we learned about substitution. This is where we will isolate one of the equations for one of the letters, then we'll sub it into the other equation, solve for one letter, solve for the other letter, and then you get the solution to the system. The new method for this lesson is called elimination. So it's you're going to line them all up, like all the x's, all the y's, all the constants up, and then you're going to add or subtract to eliminate one of the variables. So it's like substitution, but a slightly different start to the method. Okay, but then like kind of the rest of the method looks the same. So you have your note here. So it's just kind of giving a quick overview of, okay, this is what you did when you graphed. You had a linear system, and then you had to graph it. You find the point of intersection, you check it to make sure it's good, and then you write the solution to the system is, in this case here, 1, comma, -2 in brackets. Okay, so I wrote down a list here. Okay. The next one is the substitution method. So if you're like taking a look through here, you have a couple linear equations. You solve one for one of the letters. So in this case, the second one will solve for y. You sub it into the first one. You go through solve it for x. Then you go find y, and then make your final statement. The solution to the system is. And with elimination, if you want to just see a quick overview, what you're going to do is you're going to take your two equations that you start with here, and you stack them so that the x's all match, the y's all match, and then the values, wherever they are, the constants, they all match. So here they all line up. So we're going to stack them up, and we're noticing that if I add or subtract here, I can get rid of one of the letters. So in this case here, they've decided to get rid of the y's. So if I add these equations together, y plus, think of it as negative y, becomes 0y. So y is gone, it's eliminated. So that leaves just the x, and then you can solve through everything else looks like the substitution method. Okay, so we're going to go through those steps right now. So here is an example here. Here's a linear system, 3x plus y equals 19, 4x minus y equals 2. We are going to use all three methods just as a review. And then today, this is the elimination method is the one that you need to pick up for this cycle. Okay, so I'm going to go through and show you all three methods. So again, if you're like, I know how to do these, just skip right to the elimination example. Okay. Okay, so we're going to start here with the graphing method. So we're going to take this linear system here. So again, remember, linear system means, or we say linear system because we have more than one equation that we have to deal with, and we're trying to find a solution that works for both of the equations. All right, so we're going to solve the system, try to find that x and y value. So our goal here, okay, is to find that x and y value that works for both of them. All right, so let's start off with the first equation here. So like this is equation 1, equation 2. So I'm going to take equation 1, and I'm just going to, I'm analyzing both of them right now, and I'm thinking, okay, I need to make them both equal to y equals mx plus b form so that I can graph them on the graph there. So let's start with the equation number 1. Okay, so our goal here for this step here is to make it look like this. Okay, get the y on the left side, and then the mx plus b on the right side. So if you're taking a look here at the equation number 1, I see the y, so I'm just going to move the x over to this side. When I do that, I'll get negative x, and then that 19 is still positive, and then I have my y equals mx plus b form. So while I'm here, I'm just going to find the slope and the y-intercept. Okay, so my m value here is -3, and again, I know a lot of you like to write it, well, okay, so that means like 3/1, rise over run, and then your y-intercept is your the 19, the constant here. Okay, so before we graph, let's find the y equals mx plus b form for the other equation, equation number 2. So that's 4x minus y equals 2. Okay, so again, we're trying to find the y equals mx plus b form. So a few different ways you can do this. In the end, you need to have y equal to y to be positive. So let's see here, if I move the y this way, okay, so it's positive y there. Then I'll move the 2 this way because we want y by itself. So that's positive 2 becomes subtract 2 on this side, and that equals y. So now, slightly different way, but we still got to the y equals mx plus b form. Okay, so find our slope here. Our slope here is 4, or some of you would like to think it is 4/1. And our y-intercept is -2. So we're going to go through and graph those. So I'll start with the first few points here. So let's start with the equation number 1. So where y-intercept was 19. So we have a problem here. Our graph isn't big enough, so I'm just going to go grab a different graph here. Okay, so I found a nice big graph online here. So this one goes up to 19 and 14 on the sides. All right, so let's start with the first one here, equation number 1. So the y-intercept is 19 and the slope is -3/1. So remember, this means that it's a drop over run. Okay, so I'll just add that note here, make it pink. So in this case here, it is a drop over run. Okay, so plot your y-intercept first, then drop run. Here it's +4, so this is a rise over run. Okay, but the key here is plot your y-intercept first. So we're going to do equation 1 first. So plot that 19 is your y-intercept on our big graph here. So y-intercept, our dot should be right there. I'll make it nice and big so you guys can see. All right, and then from there, the slope was -3/1. So we're going to go down 3 squares from that dot. 1. Okay, so here's the dot. 1, 2, 3. Okay, and then we're going to run over 1. So 1, 2, 3 over 1. Here's the next dot. And again, I know a lot of you like to draw more than 1 or 2 dots. You just need 2 dots per line, but if you want to keep going, 1, 2, 3 over 1. That dot. Okay, 1, 2, 3 over 1, etc. Okay, and then we're gonna draw our best fit line. I draw a line through here, so you guys need to use a ruler. I assume you're on paper, yeah, just make sure. Again, I know I made my dots really big, but you should be going through those crosshairs here. Okay, so when you guys draw a line, the crosshairs, see where the plus forms? That's where you should be drawing your line through, not through like the side of your really massive dot here. Okay, so here is our line now. So again, if you are doing this in Microsoft Word, like I was, there's insert shapes option, and then there's lines that you can draw, and then you just gotta fiddle with it so it lines up. I can see that it's off a little bit, so I'm gonna fix that. But then, yeah, just make sure you do that, and then go through and plot the next line. Okay, so the other line, the equation number 2, the slope was 4/1, and the y-intercept is -2. So again, plot the y-intercept first. Okay, so -2. Make making a dot right now. Okay, and the slope was 4 over 1. So that means you have to go up, rise up 4, and then run over 1. Okay, so from this dot here, 1, 2, 3, 4 squares over 1 square. And then put your dot. Okay, keep going if you want. Another dot. Another dot. And hopefully you just saw, oh, look, it intersected at that point. Yes, it did. There. Okay, and what I'll always do this year is whenever I give you guys an equation, a system, a linear system to solve when it comes to graphing, I'll always make sure it's a nice one where it's going through a nice point like that. So if it's not and you know you did everything right, just start asking questions. Okay, so I'm going to draw our line through the red dots here, and then we're going to look at the point of intersection. Okay, so we've drawn the line in for the red line, the second equation, and again, I labeled them. Okay, so again, get in the habit, label them, put arrowheads on things, use a ruler when it's a line. All right, so we're noticing here that the point of intersection is okay, so read here 3 and 10. Okay, so just a reminder, write the x first, then the y. Okay, so I'm still seeing some of you writing these backwards. All right, and again, if you wanted to go through and check that in both linear equations here, it will work. The left side will equal the right side, and then you can say, all right, therefore the solution to the system is 3, 10. Okay, so that's solving linear systems by using the graphing method. Okay, so let's move on to the second method that we already know how to do, just as a review. It will be the substitution method. Okay, so we're going to try that here. Okay, so here's the substitution method. With this method here, we need to take one of the equations and sub it into the other one. So in order to do that, we need to make one of the equations equal to one of the letters. So if you're analyzing both of these equations, you'll notice that y looks like the simplest one to solve for. So you can solve for this one, or you can solve for this one, just doesn't matter, just make a decision and go from there. So I'm just gonna solve for the first one here, solve number 1 for y. Okay, here's number 1, number 2. So we're going to solve this one for y. So I'm going to kick that one across. And there we go. Okay, so there's one. It just looks different. Just solved it so that it's equal to y. So then from there, we can sub in 1 into where the y is in number 2 here. Okay, so we'll do that underneath. And then again, whenever you sub anything in, always use brackets. So here is equation number 2, 4x minus y equals 2. Okay, so I am subbing in equation 1 into here. So 4x subtract, so I'll use a different color here. So we're putting equation 1 into where y is, so we're subbing it in, replacing it. And then writing everything else that we see. Oops. Okay. Okay, so when you take this first step called the substitution step, you're going to find that the equations started with 2 letters, x and y, and now when you sub it in, it only has the 1 letter, so it's much easier to solve now. Okay, so let's do that now. Okay, so I'm multiplying this negative in, so it becomes positive 3x. So it's like multiplying a negative 1 in. And then negative 19 equals 2. Okay, collect like terms up. That becomes 7x. Okay, I'm going to boot the 19 over. When I do that, see this is subtract 19, it becomes positive 19 over here. Keep going, clean it up. And you get to 21. All right, and then let's boot the 7 over now. Okay, so it was multiplied onto x, so when you throw it over here, it'll divide away, and you get to 3. Okay, so we're halfway there. Remember, our goal is to find x and y. So we found x, so now we're going to go find y. So I'll do y right beside here. And I don't know, pink, yes. All right, so I don't know, that was step A. Now we're going to step B. Okay, so we have found x was equal to 3. Okay, and then now you want to go and always, this is a rule of thumb, always put it back in the original equations, because if you did something wrong here and solved it wrong, and you go through and then you check it back in your wrong equation, it's going to come out okay. So you want to always put it back in the original. So I'm looking at both of them. They look both equally nice to put into. Okay, you always want to find the simpler one, but they're both good. I guess I'll use equation 1. Okay, so again, you are now subbing this in where the x is, right there. Okay, whenever you sub stuff in, always just put brackets around. Okay, so the x equals 3 got subbed in, there it is. So follow bedmask, multiply that out first, 9. Okay, and now solve for y. Okay, so let's put this 9 out of here. And we get to 10. So again, if we go through and double check our work and you check the left side equals right side, you'll find that this is the correct solution. And on top of it, we just did one with graphing up here, and we found that the answer was also 310. So we're on the right track. Okay, so to get that last mark, remember to make a therefore statement for the solution to the system. Okay, is, okay, always write it in the point coordinate form, 3, 10, bracket. Okay, so that was a review of the methods that we've already covered. We've already covered graphing in one cycle, then we did substitution in the next cycle. So now we're ready to move on to the new method for the cycle called elimination. Okay, but the goal is the same. You're trying to get the point of intersection, the solution to the system, okay, the x, y value. You're just going to approach how you find the answer differently. So again, we've had the graphing method. We've had where you rearrange it so you sub it in right at the beginning. So elimination, this is the next method, is slightly different how it starts, but then it does look quite a bit like substitution. All right, so we'll start with those two equations that we've just been working on, and we'll use the elimination method. Okay, so step 1, you want to stack them up. So here is equation 1, here's equation 2. So I'm going to stack them up. And I want to make sure that when I do stack them up that they are all lined up. So the x's are together, the y's are together, the equal signs in the same spot, and then the constants are together. Okay, so if they were all on one side, all equal to 0, that's okay. The constant can be over here, the y could be over there. It's just the main thing is when you stack them, they are all lined up nicely. Okay, so from there, you're going to draw a line, because you're going to now decide if you're going to add or subtract these. So from there, you have to decide, okay, well, what letter could I wipe out? Can I eliminate? So if you're looking here that you have a 3x and a 4x, they're not the same. So even if I add them, they won't go away. If I subtract them, it won't go away. But if you're looking here at the y, they have the same coefficient. So it's like a 1 and a 1. One's positive 1, one's negative 1. but I could tweak these so if I add them, it can make 0. So that's my goal. I'm trying to make one of them 0. All right, so you have to decide, you know, are you going to add or subtract? So here's a rule of thumb. If you find that the ones that you want to get rid of have opposite signs, I want you to add them. Okay, so maybe we could write this somewhere here. Okay, I'll just do that here. Okay, so here's a rule of thumb. So if when you stack them up and you have some variables with the same numbers, okay, they may not be the same sign, but they have the same numbers. So this is like a 1y, 1y. The rule of thumb is if they have opposite signs, so one's positive 1, one's negative 1, I want you to decide that you're going to add these equations together. Okay, so you're going to add these equations together. If the signs were the same, so they were both subtract, or add and add, then I want you to use subtract. You want to subtract these equations together. So in this case here, we want to get rid of y. We're going to add them. Okay, so I'm going to do this, and I always put a circle to remind myself that I'm adding these, and then it's not some sign that belongs to the 4x here. Okay, so add them, not the 4x here. Okay, so let's go through, add these together. So right now I have 3x plus 4x. So I'm going to go 3x plus 4x is 7x. Okay, so the next one is it's like positive 1y plus negative 1y. Okay, so that cancels out, becomes 0. I'm not going to write that. I'm just going to leave it blank. And then the next one here is 19 plus 2. Okay, also bring the equal sign down. Okay, so when I add those, I'll get 21. And that is kind of like what we had above with this method. 2 here, okay. 21 over 7 equals x, so we got to here. And we did it a lot faster with this elimination method. So that's why some people kind of go, oh, I like this method better. Some people like the substitution method better, okay? Graphing is awesome too, like for visual learners, but it's just more, graphing, it's hard when you have a fraction answer and so forth to get an accurate final solution. Okay. Okay, so that was our first step in the elimination method. You stack them up, you make a decision if you're going to add or subtract them. And then if you look here, it really quickly goes right to finding one of the values of the solution. So in this case, x. So we're going to just keep going here now. So we have the 7 here, so I'm just going to boot that over. Okay, it was multiplied, so I'm going to divide it away. X equals 3. Okay, and then when you're done, I have the step-by-step rules here on the right so that you can kind of follow and kind of go through and double check your work. All right, so we'll keep going here. Now that we found x, okay, everything's just like the substitution method now. Go put it back into one of the equations that you started with. And again, rule of thumb, use one of the ones at the beginning, okay? So I used 3x plus y last time for the substitution method, so I'm going to use this one here. Just change it up. Okay, so x is equal to 3. The equation I'm going to check it in will be 4x minus y equals 2. Again, plug it in. When you do that, put it in brackets. We don't know our y value, that's our goal. All right, multiply this out, that becomes a 12. Okay, and from here, it's up to you. You could kick the 12 over. Some people like to move the y first, but okay, let's kick the 12 over. So it was a positive 12, becomes subtract 12 over here. And then we get to 10, okay, but then we have a negative y. We don't want that, so that's like having a negative 1y there, okay? So divide by the negative 1 on both sides. Some people just like to think of it as flipping it over, so that works too. All right, so then you get to y equals 10, which is what we had before, and then make your final statement. Therefore, the solution to the system is 3, 10. Okay. Okay, so that example is a nice kind of like a level 3, like it's an easier elimination solving system type question. I'm going to give you one we're going to try one now that's a little bit trickier. So if you scroll down to the notes, if you're taking a look here, you have a whole bunch of other ones that you can try. So if you're looking here, this is a really tricky one where you got to solve your way through. And then if you're looking at the answers already here, some of these turn out to be fractions. So, and some of these I think you have to deal with fractions as you go through, even though they come out to a nice number. So anyway, so just as you go through, if you need a bit more of a challenge and you want to be able to show a level 4 ability, try to do these ones with level 4. But to start off with, we could start with a level 3 question, another one of those. I'm taking a look here, level A here. These are already nice and lined up, so it's easy to just kind of take out the Y here. I'm going to try, for example, maybe this one here, D. So if you're taking a look here, the X's have different values, the Y's have different values. And so how do we deal with something like this where it's not straightforward as to how to get rid of one of the variables? Okay, so we're going to try D now. Okay, so I just copied D over down here, so we're just going to do it down here. Just as we're going through though, take a look here. These are the textbook questions that you can try, okay? Once you kind of see these examples and want to get some more practice. Again, please practice a few before you try some of the checkpoints. When I was marking some of the checkpoints from last week, I found that a lot of you seem like you kind of looked at my video and then just tried it without practicing. So just give yourself practice a little bit and then check your work, make sure the answers are right, and then tackle the checkpoint. All right, so here, let's do this. This is D here, okay, do it here. So what's different about this one compared to the last one is that when you line them up, in like the previous example here, when you line them up, the Y was nice. They both had a 1, so it was easy to eliminate. So we have a different situation here where we have the X's 2 and 5, and then the Y's 1 and 3. They're not the same, so we have to use a slight modification here in order to get through this question. All right, so I'm going to label them both, again, equation 1, equation 2, okay, so you know what I'm talking about. All right, so they're already like lined up nicely, so the X's are together, the Y's together, the numbers are together, the equal signs together, but you just have to make a decision here. And again, you can go by like what's going to take the fewest number of steps to solve this. I'm looking at the X's here, they're not the same, the Y's aren't the same, but if I multiplied the first one, equation, by 3, then I'll get the same value here. So you're allowed to do that in math where if you're going to modify something, an equation, as long as you multiply everybody by that same value, it's okay to do that. So with this one here, I'm going to multiply the equation number 1 by 3. Okay, so let's rewrite that if we have make that change. So equation number 1, 2 times 3 becomes 6x. The y times the 3 becomes 3y. Okay, and then 18 times 3, it becomes 54. Okay, so there is, I don't know, it's like another version of equation 1, so we can call it 1a or something like that, okay? But still, it's the same. I just multiplied them all by 3, and then I'm going to write equation 2 right underneath. I didn't change that one at all. Still the exact same. Okay, and I'll write equation 2 because it's still equation 2. So now from here, we can use the elimination method because we can try to get rid of the y. Okay, so we just have to decide here. What are we going to do here, though? Are we going to add or are we going to subtract these equations together? So again, remember our rule of thumb from above. If the variable that you're trying to get rid of, if they have the same sign, I want you to subtract. But if they have the opposite sign, I want you to add. Okay, so we're going to add these because they have the opposite signs for the y's. Okay, so go through and calculate these out. So 6x plus 5y is 11x. Okay, positive 3 plus negative 3, the y's are gone, equal sign comes down, and then we have 110. Okay, so from there we have a simpler equation, so quickly getting to the x value here. All right, so let's kick the 11 over, and we're going to, it was multiplied, so we're going to divide the 11 away. Okay, and then get to 10. So again, go through all these steps. Be careful. If you make a little mistake, it's going to throw everything off, so always be double checking your work as you go through. All right, we found our x value. So let's now do the second part, because remember our goal is to find x and y. So here is x, has been found. Okay, and again, you were just picking one of these original equations to plug that into. So again, I'm looking at, I don't know, the simpler one. One looks simple compared to two. Doesn't matter though. So I'm going to use that one there. 2x plus y equals 18. I'm going to plug the x right into there. Okay, crunch the numbers out here and solve for y. Okay, and therefore then you're getting the, again, the point should be written like this. Right, and so again, check your work, get the habit of checking your work using the left side, right side check. Again, the answers are up here though, you can take a look. So remember, this is question D, so I'll just write D here. This is question D, and if you look here, D so far, so yep, so far that's what they got there for D. Okay, so that's how you know you did it correctly, but you can also do a check. All right, though, to get full marks though, don't forget to write a final statement. Okay, so the solution to the system is 10, negative 2. And again, pay attention to the instructions, right? So it says here, use the elimination method to solve the linear system. So whenever you see that, solve the linear system, you know that your final statement has to be, okay, the solution to the system is 10, negative 2. That's what you are doing here. You're solving these equations here in order to find this, the solution here. Okay, so that's the only time that you should be writing this type of final statement, the solution to the system. Okay, I don't want to see it in other places. So, all right, so there was a slightly different one, so we can level up and try another more tricky one, and then hopefully with those 3 examples, you'll be good to go. Okay, this one is a G from the practice ones that I had from above. Okay, so let's try this one out. So this one I wrote level 4 because if you can handle this one, you can get through this one, you are showing me that you are at level 4 capacity, you can solve equations great, you can deal with fractions, you can use this new elimination method and so forth. And on top of it, it's a little tricky because you have the M and N variables, okay? So sometimes that throws people off when it's different letters. Also, if you'll take a look right now, if you're looking to see if they're lined up, they're not even lined up. So you have to throw everything at it with this question here. All right, so let's go through. We're going to start with, I don't know, I'll label them both. Okay, so equation 1, equation 2, right now they're not lined up, so I'm going to rearrange everything to look like equation 1. So let's get the m over here for equation 2. And let's, rewrite it. So we have positive 5m, and then positive 8n is still there, leaves a 9 behind. Okay, so now it looks more like equation 1. Okay, so I don't know, what we can call this equation 2A. Okay, still the same equation, just slightly different. All right, so I'm going to now stack them up, analyze it from that point of view. So we have our equation 1 and our equation 2. Okay, there's 1, equation 2a. All right, so when they're lined up like this, the letters are all lined up, the m's are lined up, the n's are lined up, the equal signs lined up, the constants are lined up. So from here, the first step for the elimination method is that we have to try to eliminate one of the variables. We're looking here to see which one's easier, but right now, like with the previous example that we did, we just multiplied one of these equations by a number and then it was easy to cancel out. But if you're looking here, even if I multiply 3 by something, I'm never going to get 5. If I multiply 7 by something, I'm never going to get 8. Or vice versa. If I multiply 5 by something, I won't get 3, and so forth. So what's going to happen here is that we have to multiply both equations up to a number, so that with some numbers, so that one of these letters will end up being the same value. So you just have to decide what you want to do here. You can, like if I'm looking at 7 and 8, what do they have in common? 56. So you can multiply both these up to equal to 56. I'm looking at the 3 and 5 here. What's a common multiple here? 15. Okay, so this is maybe a smaller multiplication, so and that way you don't end up with large numbers, but it doesn't matter. If you decide that you want to make the n's the same or you want to make the m's the same, it doesn't matter in the end. It'll still come out. So we're going to, our goal here is to get rid of the m's, okay? So I'm going to get the m's to look the same. So right now I'm trying to get the 3m here to look like 15, or to become 15. So in order for me to do that, I have to multiply this first equation, the whole thing, by 5. And the second one, I have to multiply the whole thing by 3, and that'll make both of them 15. But the key here is, don't forget, multiply everybody by the 5. Okay, sometimes people will go through and they always forget like the constant for some reason. So just make sure everybody changes here if you're going to do this. All right, so let's do that now. And we'll write them in any color here. Okay, so the first one here, the 3m multiplied by the 5 becomes 15m. 35n equals 55. Okay, so this is my new equation 1. All right, and equation 2a is going to be multiplied by 3. All right, now I'll just give it a new name, 2b. All right, so if we're taking a look here, you just make sure, double check your work. Everyone got multiplied by 5. Yep, everyone here on the second one got multiplied by 3. Yes. Okay, so now we can start rolling with our elimination method here. Okay, so that's the key step to show, okay, you're stacking them up, putting that line under, and then you have to decide, are you going to add or subtract these? So in this case here, if you're looking at 15m and 15m, they're both positive 15m. They both have the same sign, so you're gonna subtract. Okay, so they same sign. Some of the rule of thumb, subtract them. Okay, if they were opposite signs, then you'd add them, but you're gonna subtract them. Okay, so if you do that, then you will get 15m, and 15m will cancel out, become 0. So you have 35, and so you have negative 35, subtract negative 24. Okay, so then you're going to get negative 59. And then you have on the other side the equal sign, 55, subtract 27. 28. Okay, and then go through, throw the 59 over. It's multiplied right now. Okay, and divide it through. Leave things as fractions, but reduce the fraction. But here we can't reduce this. Okay, so now that we've found our n value, let's go find the m. So I'm just going to erase this same sign rule out here. Okay, so let's change to green here. Okay, so we have n is equal to 28. 59. Okay, and again, some of you are like, where can I write that negative sign? You can write it right in the middle if you want. Okay, but I always just move the negative right up to the top. Okay, use it that way. Again, so I know we're getting probably stressed here. We got a fraction we have to deal with. Yes, so this is why we practiced our fraction operations at the beginning of the year and solving with fractions, so that whenever we saw one, we could tackle it. We can get our level 4. All right, so taking a look at the equations to sub it into, looking at both of them, they both look tricky to work with. Our goal is to find m, so it doesn't matter which one you use. I'm going to use, let's see here, I'll just use the first one. There it is. So I'm going to plug n into this equation. So when I do that, I'll just change it to a different color here. Okay, so this is this part here. So we plugged it into n. This part here has plagued a lot of you. So just as we put it in here, I don't want you to go and try to find common denominator yet. I want you to take a look and go, okay, well, let's see if I can just clean this operation up first, and then we can do the common denominator step. So if we take 7 times the 28 here, okay, so we're going to get 3m. Okay, so negative makes positive. 196 over 59. Okay, and again, can't reduce that, so we'll leave it like that. Okay, and then from here, you can use your common denominator trick. Okay, so we know our lowest common denominator, 59. Okay, so let's make everybody have a common denominator, 59. Okay, I'll just write the little ones underneath. And for us to get to a common denominator of 59, I need to multiply this by 59, and therefore this by 59, this by 59, and so forth. Okay, and then we get to 177m for this first one, all over 59, and then we get to, well, this one doesn't change. And then 649. Okay, so now we have a common denominator here. So the next step is to drop that common denominator. Okay, so that eliminated the fraction. Let's give myself a bit more space here. And now you're just going through and solving. So we're going to boot the 196 over. $453. So hopefully you're seeing why this is the level 4 question. If you can do this, you can do any of these. All right, boot the 177 over. Okay, and let's see here, I think this can be reduced down to 150, 159. Okay, so if you're like, what? How did she do that? I just divided them both by 3. Okay, all right, and then we get to there. Yay, we're finally at our solution here. So make your final statement. Okay, so remember to write the solutions, the systems in alphabetical order, right? So M comes first. And then the N, don't forget the negative, comes next. Okay, always alphabetical. Okay, I know it was a little messy because it's different letters, but still general rules apply here. So here's the final answer. Don't forget brackets. Okay, so again, if you can do that, you can do any of these. So just try a few more, try some of the level 3 ones. So again, if you're like, is that right? Go back and you check the work here. Yep, that's the answer. That's the answer here. If you want another one with fractions, F looks like a nice one. Okay, H comes out to a nice value, but it takes a lot more hacking through, so you have to kind of clean it up a bit before you go through the question. So it's a nice challenging one. And yeah, just go through, show the work. So the key here is that you need to be able to show that you know the difference between substitution method and elimination method. So elimination method, you stack them up like this and you kind of go from there. Substitution, you have to solve for one letter and sub it in. But in the end, the second half of the question, it looks just like substitution. I go through here, write a final statement, and again, always check your work. I'm not showing that step, but if you check it, it'll work as well. Okay, all right. So again, try the checkpoint once you've had some practice and submit. Thank you.